All right, for lesson A1 in algebra for your notes, first off, hopefully you're able to get your letter written and get that turned in to me. So make sure you turn that in to the sub, please, or to Mr. Nelson, who's filling in for me. What I would like you to look at in your notes is as you look at lesson A1, all types of numbers. So one of the things that we're looking at today is being able to classify the numbers in different categories. So these are the standards that we are looking at in the I can statements. I can classify real numbers as rational and irrational according to their definition. Tell by examples if they're rational or irrational. Explain if the sum of two rationals is still rational. The product, is it rational? The sum of a rational and irrational, show where it's irrational. And explain how the product of a non-zero rational or irrational number is irrational. So those are our I can statements. First off, I want you to think about the different types of numbers that we have. So, different types of numbers. One of the first things we're going to talk about is we have real numbers and we have what's called our imaginary numbers. The imaginary numbers is something you're going to worry about when you get to Algebra 2. So imaginary numbers and our real numbers. Almost every number that you deal with this year in algebra will be a real number. Now, when we have our real numbers, from that we have two different categories. So the real numbers, if you want to think about that, that is going to be every number on your number line. Okay, and we're going to talk about that a little more specifically on the top of the next page where we put some definitions. Right now, real, our next category is one of our top ones that we had there, rational. So when we're thinking about a rational number. Now, if we have rational, we also have irrational. Irrational is not Mr. Nelson. Irrational. It is not when your parents say, "Why did you do that?" It's a special type of number. When we talk about rational numbers, we are also going to talk about the next category down, which is going to be integers. And again, on the next page of your notes, we're going to look a little more specifically at filling in these definitions. What is a whole number is our next one. So getting more specific is a whole number. And our most specific type of number that we are going to deal with is called a natural number. So when we're thinking about numbers, these are our different types. Now, if you need to pause the video to make sure everyone gets this written down, please do so before turning the page. So in your notes on the top of the next page, we're now going to look at the definitions for these types of numbers. So when we are looking at the definitions for the type of numbers, when we look at real numbers is a value that can be found on the number line. So whenever you're talking about a real number, what you are really talking about is a number that can be found on the number line. And I know this is hashtag, but it also is a symbol for numbers, so number line. And I'm using a little shorthand here. Imaginary is a number that is not real. So imaginary number is a number that is not real. What do I mean that it is not real? It's not real in that it might be the square root of a negative number, like -1. That is not real. So under our rational numbers is all decimals that end or repeat and all fractions. So we're going to start, it's all fractions, mixed numbers, fractions. It is decimals that repeat or end. If it doesn't repeat or end, it is irrational. So when we think of our irrational, it's a decimal that does not repeat or end. I hope you like my joke. Integers are, when we think about that, and I think what's going to be the best way here for me to explain this is we're going to start at the bottom. Natural numbers, there are counting numbers. So when you think of that, that's like 1, 2, 3, 4. That means it continues on. When we think more getting a little more specific is whole numbers. What's different from natural and whole numbers is it starts with 0. 0, 1, 2, 3, and then keep going. Now what are integers? You worked with integers quite a bit last year in your pre-algebra. Integers are both the whole numbers and their negatives. So when you think of whole numbers and their opposites, so integers are really the whole numbers and opposites. So if I was going to make a list like I had of the last two here, I might say I have 0, 1 and -1. I have 2 and -2. Notice there are no fractions, 3 and -3. And I could list them that way. So it is always including 0, and then we are talking about it being the whole numbers and their opposites. Hope you enjoy the joke there. What we are going to be looking at doing is when you add and multiply real numbers, there's a few patterns that are always true. So as we take a look at these, when you add a rational plus a rational, like 4 plus 8, if you think about that answer, 4 plus 8 is 12. Rational plus a rational will always equal rational. Rational plus irrational, 5 plus square root 3. We actually can't simplify that unless you want to put a decimal. If we're going to keep it exact, this is our exact solution. That would be irrational. When you multiply, if we don't have 0, if I take -3 times 4 and two rational numbers, I get -12. That is still rational. And again, if you're not sure, you can kind of look at this table in your notes. Rational is all of these categories. It's fractions and decimals that repeat. It's the integers, whole numbers, and natural numbers. So when we look at this should be equal to a rational number. Rational times an irrational, 9 times square root 5. That is going to look like this. This is how we'll usually write it, 9 square root 5. That would still be irrational. It says these are 4 situations that are always true. Other combinations are not always true. And we want to wonder, why is that? Like, what if you take an irrational and you multiply it by another irrational? What do you think is going to happen? Well, let's think of some different irrational numbers. What if I think of the square root of 5? That's irrational. And what if I take it times another irrational, like square root of 5? They were both irrational. That should be, what do we think? Well, that's the square root of 25, and the square root of 25 equals 5, and this time it is rational. But what if we take another irrational, square root 2, times square root 5? Well, now we get square root 10. Square root 10 is irrational. So we want to think about those properties as we are going forward. When you multiply two irrationals, it could be either rational or it could be irrational. And I want you to think about, well, what happens when we take two irrationals and if we are adding them. So now at the top of the next page of your notes, it asks you to put down, so I just want you to do these, and we're going to pause the video, and it says just put down rational or irrational. You do not have to solve. So you can put an R for rational, and you can put an I for irrational. So what I want you to do is think about what the answer is and fill that in. And then I'm going to ask Mr. Nelson or the sub to pause the video. And after they pause it, I'm going to have you look at the answers. I've put the answers up for you. Rational, irrational, rational, rational, irrational, rational, rational, and the last three being irrational. And I just want you to kind of think about what those answers might look like and if you agree or disagree. And if you want to pause that and ask some questions of Mr. Nelson, I'm sure he'd be happy to oblige you. As you look at that last page, it says, can the sum of two irrational numbers ever be rational? And if so, give an example. And if not, explain why. The second question that I want you to think about is, can the product of two irrational numbers be rational? And if so, give an example, and if not, tell why. And I do want you to think about this some, and here I want to give you a couple of little hints. When we sum two irrationals, The answer here to both of these is yes. And I want you to pause the video and try and come up with what you think could be the two irrationals that when you add them, when you sum them, it equals something that is rational. So this is going to be your two irrationals. And then I want you to think, we kind of just did an example of this last one where we have an irrational and you're going to multiply it by another irrational and it needs to come out to be rational. So pause the video, try and come up with some. Hopefully you guys will come up with some different ones than the one I did. Remember, I did this one. If you need to look back in your notes for the product, but try and think of the sum. There are many, many, many examples. And then we're going to summarize this. All right, I put a couple examples up here. Hopefully you came up with something maybe a little different. So I want you to summarize. There are 4 types that earlier are always true, but all other combinations of operations. So the first 4 that we listed under the adding and multiply, those first 4 types are always true. And what am I referring to? I'm referring back to this page. Rational plus irrational, this page right here. These are always, always, always true. When is it not always true? And this is when we are taking a look at, it is not always true when you combine operations that are either sometimes or never true. So these two situations could sometimes the product of two irrationals be rational, sometimes it could be irrational like we just showed. Same with the sum. So the 4 types are always true, but what we want to be thinking of is that the combination of operations with 2 irrationals is sometimes true. It may be equal to rational, it may be irrational. So sometimes, and sometimes it might also be never true. And I do want you to kind of think about those situations as you think about your homework tonight. Now, your textbook has lesson 2.1. Yesterday, the worksheet that we got and we did in class, that was looking at lesson 2.1 in your textbook. And when you think about that, this is not in your notes, but this is all review of last year. This is where you were showing the adding 3 to both sides and solving it and checking. So lesson 2.1 in your textbook is where you want to look if you really struggled with that. This is really some pre-algebra standards. And again, this is in the video, and it kind of shows how you can solve these. And we talked about this today, that when you have a fraction, you can multiply by its reciprocal to solve. So this is all in your notes in lesson 2.1. So if you need to take a look because you're struggling with the one-step equations, please make sure you take a look at that. Your homework in your book is going to be page 45, but then I am also putting a worksheet, and the worksheet is I believe it's A4 and A6 that you are. All right, so as you look at your homework, first 6 answers, please make sure you only answer with the word rational or irrational. So write down the problem in your notes. You'll write this out, and then you'll write not the answer. You'll tell me, is it rational or irrational? For each of these, they ask you to determine again, is it rational or is it irrational? So write the problem and then tell me your answer. Same thing here. They're asking you to explain in the sentence and predict if the sum is going to be rational or irrational and explain. So when you give your explanation of a sentence, you can also give an example. Now, you're also going to get, this is going to be worksheet A4, that says write the decimal as a fraction or a mixed number. So when you do this one, you should be thinking, oh, 10 and 58 hundredths. And now you want to simplify that. So all fractions or mixed numbers should always be in simplest form. So you're going to simplify. Don't get too worried about the repeating decimals. We're going to go over those. That's kind of something that we'll be looking at. But the main thing I wanted you to think about is giving these examples on this page. So any decimals that Do not repeat. You can do those. So